Hello there, Mr. Sutton bringing you this lesson on segments in circles. In this one, we're going to find the lengths of different kinds of segments in circles, and as a real-life application, we will find the diameter of an ancient artifact. So we're going to see a bunch of different situations in which some segments intersect each other. Let's say we have two chords intersecting each other. If two chords intersect, like in this diagram below, the product of the segment lengths in one chord, so for example A times B, is going to equal the product of the segment lengths in the other chord, in this case C times D. So you can say A times B equals CD, and if you're missing one of these pieces but you have the others, you can solve for the missing piece. So try out this example on your own, pause the video and give it a shot. Alright, so our relationship is, we know that 6 times 4 is going to equal 8 times x, so that's 8x equals 24, which means x equals 3. Now what if we have two secants intersecting each other? If two secants share an external endpoint, like these two secants in this diagram sharing endpoint G, then the products of each whole segment and its outside part are going to be equal. So here the outside part is the A and the C over here, so we can say A times the whole segment, A plus B, equals this outside part, C, times this whole segment, C plus D. And just make sure you're adding those pieces in a parentheses. So pause the video and try this one out. Try to find the value of Z. So on this one, we can say 13 times Z plus 13 equals 9 times 30 plus 9. Distributing, we've got 13Z plus 169 equals 81 plus 270, which adds up to 351. Subtracting 169 from 351, you can do that on the calculator, comes out to 182. And then if we divide 182 by 13, again on the calculator I did this, that comes out to 14. Our last relationship is between a tangent and a secant. If a secant and tangent share an external endpoint, like in this picture here, we have this tangent and this secant meeting at Q, then the whole segment of the secant times its external part equals the square of the tangent. So just like the last rule, we have A times A plus B, but now this is going to equal just C squared. So pause the video and use this property to see if you can figure out the value of x in this problem. So here we can write x squared equals 4 times 5 plus 4. Well, this is really just 4 times 9, so 36. So we can say x equals positive 6. We would put plus or minus, except that this is an actual length, so we don't want to have a negative length. So there's two things that are probably becoming apparent at this point. One of them is that the algebra is not so bad once you've got the formula set up. The other is that there's a lot of different formulas to keep track of. So here's a practice round. Pick the right formula and use it to find the values of x in each of these three problems. Then unpause the video, or you can pause it as you go and see each solution. All right, hopefully you got all of those. Let's go through them one at a time. So for this one, we're going to use that relationship where we have the external part times the whole segment equals the same for the other side. So we can say 4 times 4 plus 6 equals 5 times 5 plus x. So that's going to be 4 times 10, or 40, equals 5x plus 25. Subtracting 25, we've got 15, so x equals 3. Over here, we've got two chords, so we just have to multiply the different parts of them and set them equal to each other. So we can say 6 times 5 equals x times 8, so 8x equals 30. And then dividing, 30 over 8, that's going to reduce to 15 over 4, or 3.75 if you want to make a decimal out of it, either way. And last but not least, we've got the outside part times the whole segment equals the square of the tangent. So we can say 7 times 7 plus y equals 10 squared. So we've got 49 plus 7y equals 100. Subtracting 49, that's going to be 51. And then we can write this answer as 51 over 7, or if you want to make a mixed number, it doesn't really matter, 7 and 2/7, either way. To wrap things up, we're going to do a real application. Let's say that archaeologists have discovered a fragment of an ancient disk. So they don't actually have the whole circle here, they just have this little piece. They're assuming the whole thing is a circle. So to calculate its original diameter, they drew chord AB and its perpendicular bisector PQ. We want to find the disk's diameter based on this, and all we know is that this segment over here, and because it's a bisector, this segment over here are both 5, and this little segment in here is 3. So pause the video and see if you can figure out the diameter from this. The relationship here is that we know that 5 times 5 is going to equal 3 times whatever this other length is. So we can say 3 times, we'll call this x, equals 5 times 5, or 25, which means that this length here is just going to be 25 divided by 3. That's not the whole diameter, though. Remember, we still have the original 3 inches in here, so we're just going to add 25/3 to 3 inches. Common denominator, this 3 is really 9 over 3, so that adds up to 34 over 3. Or you could also just make a mixed number, and that would be, let's see, 11 1/3 inches total. That's it for this lesson on circle segments. Until next time, this is Mr. Sutton signing off.